Here we will see shared database pattern in microservice architecture. The shared database pattern is a design approach in which multiple microservices access the same database. That is, the shared database pattern uses one centralized database for all services. It involves multiple services accessing a single database instance, which allows them to read and write to a shared table using local ACID transactions. A shared database is often used as a pragmatic intermediate step during monolithic migrations or for highly interdependent data domains. It is generally considered as an anti-pattern due to tight coupling. But with runtime and development time, this approach offers simplicity, data consistency, and ease of querying. Although it is an anti-pattern, it may fit in temporary situations like proof of concept or MVP, where speed matters more than design. Small teams can use this approach where everyone manages the same database without friction. It can be used in legacy migration phase where monolithic is being broken into services gradually. Reporting and analytics services that need a consolidated view, and the systems with very low scale and complexity. To minimize the risk like schema conflicts and data corruption, you can implement this pattern using several architectural approaches such as schema per service isolation, private tables per services, read-only shared views, and shared multimodal pattern. Schema per service is a hybrid microservice data management pattern where multiple services share a single physical database instance, but each service is strictly restricted to its own isolated logical schema. This acts as a middle ground between highly coupled shared database pattern and the infrastructure heavy database per service pattern, which offers a logical separation of concerns without the cost of provisioning multiple database servers. It prevents services from accidentally reading or modifying each other's data while keeping infrastructure management highly centralized. In private table per service pattern, multiple microservices share a single database server and database instance, but each service exclusively owns and accesses its own specific set of tables. It serves as a middle ground between a completely shared monolithic database and fully isolated database servers. Other services are strictly prohibited from directly querying or altering these private tables, forcing all cross-service data communication to occur through APIs or event-driven mechanisms. The read-only shared use approach is a pragmatic hybrid pattern designed to reduce the risk of shared database pattern while avoiding the high operational complexity of event-driven CQRS read models. It allows microservices to share a single physical database engine but establishes strict data boundaries using SQL views. The shared multimodal pattern within a shared database pattern allows multiple microservices to access a single unified database infrastructure while utilizing completely different data models such as relational, document, graph, and key value natively inside the same engine. This hybrid architectural approach balances the pragmatic operational simplicity of a shared database server with the flexibility of polyglot persistence. Workflow of shared database service patterns is: first, client sends the request and API gateway routes this request. Then order service receives the request. Order service reads the data from the shared database, and if product information is needed, the order service may directly query the product table in the same shared database, and then the response is sent to the client. Key advantages of shared databases are simple architecture. It gives simple architecture since only one database needs to be managed. Then easy transaction. A single database supports ACID transactions across tables. Then easy reporting. Since all data is in one database, reports can be generated with simple SQL queries. No data duplication. Here all services work with the same data source, so no data duplication happens. And easy for small projects. It is suitable for applications with a small number of services or during migration from monolithic applications. And disadvantages are tight coupling. Here services become dependent on the same database schema. Then independent deployment becomes difficult. Since it uses shared database, changing a table may affect multiple services. Then poor scalability. The database becomes a bottleneck as the application grows. Then reduced service autonomy. Services cannot independently choose different database technologies. And security risk. Since each service has access to the same database, it increases the risk of unintended data modifications.